Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 3.2.5. Your M&Ms are kind of illustrating what's going on with distributive property, otherwise known as sending in the dive bombers, as kind of the story that I've told you in the past. Distributive property is that property where you're multiplying a number times a sum inside of parentheses. The reason why the sum has to be inside of parentheses is because if it weren't inside of parentheses, your job would be to do the multiplication first before adding. And in this case, we specifically want you to find the sum first before multiplying, but you can't always do that. For instance, if you had 5, I don't like that at all. If you had 5 times 2 plus 4, you could just go ahead and add 2 plus 4 and get 6, and 5 times 6 is going to give you an answer of 30. If you do distributive property, you do 5 times 2, which is 10, and 5 times 4, which is 20, and when you add those together, you get 30, right? The same answer. So you could do it either way. There'd be no reason to use distributive property. However, if inside the parentheses you've got x plus 4, now you can't simplify inside because you don't know what x is. So all you can do is rewrite the expression as 5x plus 20. And there might be situations where it's actually better to have it in this form than to have it in that form. And so it's not like one of them is better than the other. It's sometimes we want to have it in factored form, which is how it looks here. And sometimes it's better to have it after using distributive property, which is how it looks here. So here's an example of what that would look like. If you took 2x plus 4, then it's kind of like saying, all right, this right here is an expression that represents 1x plus 4, but you've got 2 of them. So that means you've got to double the number of x's and you got to double the number of 4's to give you a total of 2x plus 8 would be the way to rewrite this expression. Okay, so that's distributive property. All right, so here we go. If we're going to solve this equation, we don't like to have these terms locked inside of parentheses. So when I suggest sending in the dive bombers, in this case, it's kind of like you're breaking your buddies out of jail so they can meet up with your friends on the outside. So send in the dive bombers. Instead of 3 times 5x plus 2, you got 3 5x's and you got 3 2's. So 15x plus 6. Now we can go through the process of subtracting 8 x's from each side and subtracting 6 from each side to give us 7x is equal to 14, and that means that x has to be equal to 2. So, you know, we always want to check it to make sure that that is correct. 5 times 2 is 10, and 10 plus 2 is 12. 3 times 12 is 36. So the left side should equal 36 as well. 2 times 8 is 16, and 16 plus 20 is 36. So yes, we've just proven that x is equal to 2. And in a situation like this where you're sending in the dive bombers with a negative number, remember negative 2 times x becomes negative 2x, and negative 2 times negative 3 becomes positive 6. This 4x is not affected by distributive property because it is not inside the parentheses. So it only applies to the terms inside parentheses that are being multiplied times the number on the outside of the parentheses. On this situation, in this case, that negative sign means -1 being multiplied times every term on the inside. So that means you're going to change each one of those to their opposites. So the opposite of -6 is, the opposite of negative x is positive x, and the opposite of positive 1 is -1. So once we combine like terms, then we can go through the process of solving the equation. Combining like terms, remember, any of the terms that have the exact same variable raised to the exact same power get combined. So if you can color code them, sometimes that works nicely. What I used to do when I was in school was I would draw a box or a circle or a triangle around the terms that needed to be combined. So the 2x squared has no one else to combine with, so it's going to stay as 2x squared. The x, the 3x, and the 8x all get added together. So there's 4x's plus 8x's gives you 12x's. And then -3 and -5 make -8. So we took a 1, 2, 3, 4, 5, 6 term expression and simplified it down to 3 terms where every term is represented once, right? You got your x term, your x squared term, and your constant term. Okay, so take a look at the answers. This one, problem B, often gives students trouble because they are not quite sure what they're supposed to be adding here. But remember, this is 1x. So that would be 1x minus 0.2 x's, which means you're supposed to take 1 and take away 2/10 from that. So if I took 1 minus 0.2, you get 0.8. And so that is your new coefficient. 0.8 x's is the simplified expression here. If you need me to work out B or C, let me know. Otherwise, I'm going to move on. All right, Lewis recorded how many times he could jump rope without stopping. Here is his data. All right, so he had some good runs, 102 and 100. He had some that he didn't do as well, where 15 and 29 and so on and so forth. So if we are going to create a data display like a box and whisker plot, we'd want to put all these numbers in order from least to greatest. The minimum is 15, the maximum is 102, and then find the median and the quartile. So the median itself is a number that falls directly in the middle of the data. Since we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data, the one in the middle, there's only going to be one, since there's an odd number of numbers. So that one number in the middle is 61. To find the lower quartile, you have to take all the data that is less than the median. So we've got 1, 2, 3, 4, 5 numbers less than the median. So the lower quartile is the median of the lower half, and the upper quartile is the median of the upper half. So lower quartile is 48, the median is 61, the upper quartile is 97. It did not ask us to create a box plot for this, but we could because we know our minimum and our maximum. So you've got all 5 data points that you would need to create a box plot, but we're not going to because they didn't ask us to. All right, find the area and the perimeter of this shape. Yikes. All right, well, it's not too bad, right? You've got a rectangle in the middle, and we know the formula for a rectangle is base times height. And if you combine this side with this side, you get a complete circle with a radius of 1.8 meters. So to find the area of the rectangle, let's just take the base, which is 6 meters, times the height, which apparently is the diameter of the circle, which would be 3.6 meters. So that's going to give us the area here. 6 times 3.6 is how much? 21.6. This is 21.6 square meters. Now, how do you find the area of any circle? Pi r squared, right? So let's take the radius and square it. 1.8 times 1.8 gives us 3.24. And now let's multiply that times pi. And that ends up being 10.178. Let's round that. Let's round it to the nearest 10th. So I'm going to round that to 10.2. So the circle part is 10.2. So when you add those together, you get 31.8. I guess I didn't round it before. 31.77. It's close. 31.8 is also an acceptable answer. Now for the perimeter. Perimeter, this is 6 and this is 6, but we need to find the circumference of the circle. So that's half the circumference and that's half the circumference. So circumference is pi times diameter, which means we're going to have to multiply 3.6 times pi. So let's go ahead and do that. 3.6 times pi gives us the circle itself has a circumference of 11.3 or 11.31. I'll leave it as 11.3 plus 12 gives you 23.3 meters. So these are complex shapes, but almost all complex shapes can be broken down into recognizable parts. Rectangles, circles, triangles, If you know the formula for rectangles, triangles, and circles, you can pretty much find the perimeter and area for most shapes, because most shapes can be broken down into those three particular types of shapes. All right, and here we go. This is the end of chapter 3, so we've got a checkpoint problem, and what you should know how to do by now is how to find unit rates. This was the big idea of 7th grade math, proportional reasoning and unit rates. So to find the unit rate, you take whatever information has been given to you, given the fact that you're working with a proportion, and you do division. So for instance, if 2 1/4 pounds of bananas cost $1.89, the cost per pound would involve us starting off with the price 2 1/4 pounds and then doing the division. $1.89 divided by 2.25 will give you your unit rate. So $1.89 divided by 2.25 gives you 84 cents per pound. So in all of these situations, probably the trickiest part is knowing the order in which they need to be set up. So what is the weight per centimeter? Well, the weight per centimeter means we're going to have the centimeters on the bottom. So take any one of these. Maybe I'll take the weight of 12 grams divided by 20 centimeters, and 12 divided by 20 ends up being 6/10. So that's 6/10 of a gram per centimeter. Here you've got a graph. We use the graph at the right to figure out the price per refill. So price is on the y-axis, and the number of bottles refilled is on the x-axis. And so I'm going to look for something that's called a lattice point. There looks like a lattice point, and there looks like a lattice point. So I could have taken where that looks like it's probably 17.5, and this is 5. So I could have taken 17.5 divided by 5, but this one looks like it's easier to figure out because this is the number of bottles is 10 and the price is 35. So take 35 divided by 10, and that's how you get your $3.50 per bottle. Now, where do you find that unit rate on the graph itself? Well, one bottle, does that look like it could be right around $3.50? It does. The way that this number line is scaled, I wouldn't trust that that's $3.50 without actually doing this math of taking 35 divided by 10, but it turns out it is. So for one bottle, it costs $3.50. That is the unit rate. All right, so take a look at these answers for the other 3 problems. If you have any questions on how to solve those problems, let me know and I'll work them out for you. Otherwise, I'm going to assume that you see your work and you see what the answers are, and you can go back into your work and see where you made your mistake if you got the answers wrong, or you can give yourself a pat on the back if you know you got your answers correct and you've shown all your work properly. All right, I think we now need to get into the mode of preparing for our chapter test, the last chapter test of chapter 3. So take care, let's get to work. Bye.
Hey, feeling good, like I should.